the input matrix I is in the size of n by 2. So n is the number of intervals, and 2 represents that we have the left endpoint of the interval and the right endpoint of the interval. So let's say our n will be just the size of this matrix, the row number of this matrix, and we can initialize matrix A to store all the lengths of the intersections of those intervals. Of course, the size of A should be n by n. Okay, and we initialize it with the 0 matrix. Now the for loop, of course, I is from 1 to n. The inner for loop, j, we started from I plus 1 to n, right? Okay. So what we have to do inside of those two loops is we need to compute the intersection of interval I with the interval j. So we need to check the left endpoint of the intersection first. So left endpoint A will be the maximal number of the left endpoint of interval I with the left endpoint of the interval j. So basically, this I represents the interval I, and this j represents the interval j, and 1 represents the left endpoint. So basically, we compared the left endpoint of those two intervals and find out the maximal one, give the value to the variable A. Similarly, B is the minimum value of the right endpoint. The right endpoint is the second column. Okay. And also, we need to care about when sometimes A is greater than B, then the intersection will be just an empty set, right? And the length of the empty set is just 0. And otherwise, all other situations, the intersection is just the difference between B and A. So we already know that the intersection, if the intersection is non-empty, then the interval should be this, AB, and the length of interval is B minus A, right? Okay. And basically, that's all we need to check. And at the end of the loop, outside of the loop, we can make our output. This is our output Y, right? And let's say our output Y will be the sum of all the entries of the matrix A, right? Okay, so let's test that. So let's test this with our example. So our example says we have interval 2, 6, 1, 5, 3, 7. 2, 6, 1, 5, 3, 7. Okay, so that's the first interval 2, 6, second interval 1, 5, and third interval 3, 7. And we call this function, and input this I, and we expect the output should be 8. Okay, so it works. Okay, and now we want to simplify this function. So what can we do? So we always start from the most inside of the loops. Okay, so the inside of the loops, what we need to worry about is this if else. We want to drop this if else. So a common way in MATLAB to do that, right, is that, okay, so when a greater than b, we want the value of a, ij, equal to this value. We want to make it equal to 0. And when a is smaller or equal to b, we want it to be b minus a. So in MATLAB, in general, we can write it in this way. Okay, so this is the judgment of this if. So that writes a greater than b. Okay, let's just copy that here. So when that happen, its value equal to 0. So we copy the value here equal to 0. Plus otherwise means when a is smaller or equal to b, right? Otherwise, the value of aij would be b minus a. B minus a. Okay. And then we can delete this if else. And of course that works. Right. Equal to 8. And we can keep simplifying it because that's 0. So no matter what happened, it always equal to 0. So we can delete that. Right. Okay. The next things we're gonna do, of course we can keep simplifying here. So there are some alternative way. So basically, this is when a is smaller or equal to b, we want it to be the value of a b minus a, right? And that is when b greater than a. B greater than a means b minus a is greater than 0. So when b minus a greater than 0, it's just the value of it, b minus a. And when it's smaller than 0, it's just 0. So this is actually a ReLU function, right? It's a ReLU function. So there are some alternative way. For example, we can also write it as maximum of b minus a and 0, right? Alternatively, and that also works. Okay. So let's use that expression, but you feel free to use that one as well. Now the next step, we're going to drop those two for loops. But take a look at this j. J depends on I, and we don't want this happen because we just want it to be two independent vectors. So let's make our j start from 1 instead of I plus 1. But if we modify the j in this way, we need to do something. So if j start from 1, we just count the repeating cases. So we need to drop those repeating cases. Firstly, we need to delete diagonal entries. And a minus, let's say, diagonal so we need to subtract the diagonal entries. So right now, after this line in the matrix A, all the diagonal entries of A is equal to 0. Okay, and also we compare the interval 1 and 3, we also compare the interval 3 and 1. So we just compare that repeatedly, which means we need to divide it by 2. Alright. So let's check the modification first before we get into the next step. Okay, you see that still works. Now we can drop the I and j. But to vectorize it, you need to be very, very careful.